Hello mathematicians. In the last video, I showed you how to apply a matrix to individual coordinates, and we did all those calculations to figure out where the coordinates go. In this video, I'm going to show you how to apply the matrix to a whole shape to see where that shape goes. Here we go. Now, applying a matrix to a whole shape means doing it to each of its corners, because each of its corners is a coordinate. And so the process is exactly the same as last lesson. It's just about being accurate with every single corner. What I've done to start is lay it out nicely in my book and copy down the shape that I'm using with plenty of space around it. You should do that first as well. Now, because we are doing this matrix to each of the corners, the first thing I need to do is write down each of the corners. So I'll do that now. We have the first one down here, which I'll label A, and then B, and then F. So 6 corners. And now I need to do this matrix. I need to apply this matrix to each of the corners. I'll do that down here and show all of my working neatly. So for A, we have the matrix and the coordinate. And I'll do the process from last lesson. 2 times 0, add -1 times 0. Well, anything times 0 is 0, so this is just going to be 0. And now the bottom. Again, 0. That was an easy one. Okay, let's do it to B. So we have 2 times 4, add -1 times 0. So 2 times 4 is 8. Anything times 0 is 0. So that's 8. And then 1 times 4 and 2 times 0. So 4 add 0 equals 4. And we get the coordinate 8, 4. I'm going to do that to every single one of the coordinates now. And there we go, that last coordinate. Now that was quite a lot of calculations, but it's worth it and it's excellent practice in doing all of these calculations. So make sure you persevere with it. Now what I should do, I've got these coordinates, I can draw them back on the original picture. Let's do that. So A has stayed in the same place. That'll be there. B, 8, 4. C is 6, 8. You can see why I left a lot of space around the first shape. 2, 6. -2, 9. And -2, 4. Now that looks like it's going to be quite nice. I'll join up those points. Oh, and that's beautiful. After all of those calculations, I'm very satisfied by that. How we can see that that matrix has done that. It's like made the shape bigger, it's enlarged the shape, and it's rotated it. Now, I'm fairly confident that I've been correct with my calculations because this shape looks roughly like the first one. I can still see the outline of the building. If you make a mistake and yours doesn't quite look like that, like it's maybe pulled it around, but it doesn't, you're not quite comfortable that it is still the building, you might have made a mistake, just go back and double check your calculations, maybe do them again if necessary, because when it comes out beautifully, it's quite satisfying. I'm going to finish off by just writing about what has happened, because that was what the question was. It asked, what does this matrix do? I'm going to write the shape has been enlarged and rotated. I might say rotated anti-clockwise. You might want to be more specific with that and say exactly how big it's been enlarged by and exactly how much it's been rotated by. But for now, I'm going to leave it like that and focus on all the rest. And now that is a beautiful piece of work there, laid out nicely. I hope you agree. And I can move on to the next one. So good luck with that. And I hope you enjoy that satisfaction of seeing what the matrix does.